Okay, Trig kids, I'm going to try to get through the first, 15 questions of this review today. I'm just going to start from the front and work to the back. So this is chapter R. We only have 3 chapters, R1 and 2, which doesn't sound like a whole lot. It feels like we haven't done anything this year. But actually looking at this review versus the review that I had last year with a different textbook, we actually covered more material than we did last year, and we probably did 5 chapters last year before Christmas break. So don't get discouraged. We've covered a lot of material. So we're going to try to get through 15 today. And starting with number 1, we have the subsets of real numbers. And I'm going to do like a little Venn diagram over here. So I'm going to put it like over here. We hopefully won't need this room. So this is the set of all real numbers, right? And then we have rational numbers over here on this side. And we have irrational numbers. Okay, and those are all subsets of the real numbers. Okay, rational, irrational. Outside of real, there are only a few numbers that are not real, and those are complex numbers that live out over here that are not real numbers, and those would be like imaginary numbers. Okay, so that would be what we have over there on that side. Otherwise, every other number that we have is a real number. Okay, irrational numbers are like pi, numbers that don't terminate and don't repeat. So pi, e, like the square root of any prime number. So like the square root of 2, the square root of 5, the square root of 7, any of those numbers are not going to stop or not going to repeat. Okay. Rational numbers would be any numbers that are fractions, decimals, anything like that. Okay. So although they're, I'm going to put like fractions, decimal, I'll just put fractions, decimals, anything over here, fractions, decimals, that stop would be rational numbers. Okay, underneath of the rational numbers, we have the integers. Okay, integers are -3, -3, -2, -1, 0, 1, 2, 3, etc. So like any decimals, like 1.25, that would be rational, but that would not be an integer. Okay, so that's where like the decimals like taper off, and these are positive, negative whole numbers. Okay, then underneath of integers we have the natural numbers, and that would just be 0. No, wrong. We have the whole numbers, and that's 0, 1, 2, etc. Those are whole numbers, and then we have the natural numbers. And natural numbers are just 1, 2, 3. So it's like each subset like tapers off a little bit each time. Okay, so that is like our Venn diagram of how we have things going on here. Identify which subsets of real numbers we have is this guy. So first of all, he's a real number, but I don't think we have to say that. I think after real numbers we have to say what he is. So 0.255 repeating. Because he repeats, he's not irrational, he is going to be rational. Okay, but then the next decision I have to make is, if he's rational, does that mean he's an integer? Okay, he's not an integer because he's not a whole number, right? Like positive, negative whole number. So he stops here, which means he's not any of these either. So he is just a real number and a rational number, and that is all. Okay, all right, let's hop on to factoring. This guy factoring, I've got to bump the 14 over, so I've got x squared minus 5x minus 14 equals 0, and this is a simple trinomial. Okay, I'm going to multiply to get 14, but when I add them, give me -5. So that is x minus 7, x plus 2, and x equals 7, and x equals, I'm going to write that over here because I'm running out of room. That means x equals 7, and x equals -2. So I factored him, and I also solved him. Okay, this next one, I don't have to move anything over because he's already set equal to 0. So he is a complex trinomial because the 4 is out in front here. So when we have a complex trinomial, we take 4 times 2, which is 8. And I want to multiply to get 8, but when I add them, give me 9. And that's just going to be 1 and 8. Okay. Now, it doesn't matter what order you put them in. I'm going to put the 1 first. So I've got 4t squared plus 1t plus 8t plus 2. So this guy just dropped down, this guy dropped down, but the 9 separated into 2 pieces. And now I do factor by grouping. Okay. By the way, I'm going through this a little bit speedy. So if you need to pause, go for it. Or if you are stuck on a problem and you're like, how the heck did she get that answer? Put a star by it, and I will answer questions when I come back. T is what I'm going to pull out of the first one. I've got 4t plus 1. I'm going to take a 2 out of the second one, and I've got 4t plus 1. So my two bubbles are 4t plus 1 and t plus 2. Then I set those equal to 0. So 4t plus 1 equals 0. T is equal to negative 1/4. If I subtract the 1 and divide by 4, that's one of my answers. Then this guy, t equals negative 2. Okay, again, that was kind of fast. So pause or put a star by it if you need to. And there is that. Okay. Number 4 just says solve. We're solving for W. Now, the strategy here is a little bit different because we only have W as a variable, and this is just a number, and that's just a number, right? Like up here, we had a t and then another t, a t squared here and another t here. So he was going to be a trinomial. This one is not. So to get W by itself, I could just subtract the 8 over. So I have negative 3W squared equals negative 28. I'm going to divide by negative 3, which is disgusting of a number. The negatives are going to cancel out. I'm just going to write it as 28 over 3 because it doesn't come out nicely. And then I'm going to take the square root, and I'm still going to leave it as the square root of 28 over 3, but I need plus and minus. So you have my permission, if he ever doesn't come out nicely, just to leave him as a square root. Okay, so that is the solution for number 4. That was just kind of like a solve for W type of thing. Okay, this next one is completing the square. Okay, when we complete the square, the first thing I need to do is get all the W's on one side, leave room for my blank, and then this number gets booted to the other side. So minus 3 becomes positive 3 plus blank over here. Okay, so that's the first thing I do. W's on one side if you need steps. W's on the left, numbers on the right. Okay, number 2. Let's see. What do I want to do? I'm going to say factor him. 3 is find C. Find C. Okay, and you might do those in a different order. You might find C first before you factor. But what I want to have happen is I want to break this down so that I can write it as one group squared. So I want to multiply to get this number, which we don't know what it is, but I want to add to get negative 2. So two numbers that add together to give me negative 2 that are the same. This would be like W minus 1 and W minus 1. Okay, so I can write that as W minus 1 squared. Now the thing that goes in the blank here is negative 1 times negative 1, which is positive 1, okay? And if I add 1 to this side, I have to also add 1 to this side, so I have equals 4. All right, now I'm going to solve by taking the square root. So square root. W minus 1 is just going to fall out, equals the square root of 4 is plus minus 2. And then I'm going to add the 1 over. So W equals, if it's a positive 2 plus 1, that's 3. If it's a negative 2 plus 1, that's negative 1. So those are my two answers. Okay? All right, that was completing the square. Now, most of the time when you're completing the square, it doesn't come out nicely, so it comes out as like the square root of 5. In that case, I would just write it as, I would add the 1 over, so 1 plus and minus the square root of 5 is how I would write that if it doesn't come out nicely. But since this one did, 4 was a nice number, or a perfect square, so I will write him as 2 separate numbers, okay? All right, next, quadratic formula. Negative b plus minus square root b squared minus 4ac all over 2a. All right, here is a. B is negative 8, and c is 1. So if I'm doing negative b, that would be positive 8 plus minus square root. B squared would be negative 8 squared, or 64, minus 4 times a is 4, c is 1, all over 2 times 4. I know I'm going kind of fast, so pause if you need. And here I have, okay, 8 is there, plus minus. Negative 4 times 1, this will be negative 16. So 64 minus 16, I think, is like 48, all over 8. Okay, This 48 does divide by 8, but you can't reduce all of these three things because this one is trapped inside. So you can either leave your answer like this, or 48 breaks down into like 16 and 3, I think. So the square root of 16 is 4. The square root of 3 stays the square root of 3. So if you want to, you can write it as 8 plus minus 4 square roots of 3 all over 8. And then I can divide each one of these by 4. So 2, 1, 2. This would be 2 plus minus 1 square root of 3 all over 2. And that would be the reduced version. So if you want to stop here, I'm okay with that. But that's what he looks like if you break him down some more. Okay? All right. Find the number of real solutions of the equation by computing the discriminant. Okay, when you do your quadratic formula, the discriminant is this stuff, b squared minus 4ac. It's that stuff underneath, okay? Now, I'm going to write off to the side. If your discriminant is a positive number, that means that you have two solutions. Because if he's a positive number, like it was here, 48, that means I have plus 48 minus 48. That's two answers, right? If your discriminant is a negative, that means you have no solutions because it's imaginary inside of here, right? Negative, a square root of a negative, does not work, so we have to do that. If your answer is 0, then you have one solution. And that means, or like here, if this number was 0, 8 plus 0 is going to be the same as 8 minus 0. So that's why we only end up with one solution. And what does that really even mean? That means, because each one of these is a quadratic function, that means where my parabola crosses. So if he has two solutions, he's going to do this. If he has one solution, he's just going to go down and kiss it and come back up. No solutions, he's going to be like levitating, is what my algebra kids say. He's levitating, so he doesn't cross. So that's basically what you're finding, all right? So number 7, they want us to compute the discriminant and then tell me how many solutions there are. Don't actually have to do the whole quadratic formula, but that's what we're doing, okay? First things first, this needs to be on this side. So I have 25t squared minus 70t plus 49 equals 0. Okay, I put the 70 in the middle so that I know A, B, C. B has a negative with the 70, okay? So I'm going to do b squared minus 4ac. B squared is negative 70 squared minus 4 times 25 times 49. Oh, this is going to be nice. Okay, 70 squared, 7 squared is 49, so 70 squared is going to be 4,900. It's positive. 4 times 25 is 100, times 49 is negative 4,900. Guess what? My discriminant is 0, which means I have one solution. He is only going to cross or touch. He's going to touch one place is what happens to him, okay? So find the number of real solutions by commuting the discriminant. Discriminant was 0, one solution. Done. All right, next, number 8. Whenever you have an absolute value, you need to have two cases. Case 1, case 2. I've got, the first case is just 2x minus 1 equals 4x minus 3. That's the first case. The second case, I pretend as though this is a whole negative. So negative 2x minus 1 equals 4x minus 3. Okay, so let's go ahead and let's solve the first one. I'm going to subtract the 2x, and I'm going to add the 3 at the same time. Again, if I'm going too fast, please pause. Negative 1 plus 3 is 2. 2x minus 2x is 2x. No, excuse me. 4x minus 2x is 2x. Divide by 2, x equals 1. That's one of my solutions. Okay? The second one, I'll keep that zoomed out. If I distribute my negative through, I've got negative 2x plus 1 equals 4x minus 3. I'm going to add the 2x over, and I'm going to add this 3 over. So I get like 4 equals 6x. And if I divide by 6, x equals 4 over 6, or 2/3. So I have two solutions, 1 and 2/3. Okay. All right. Hopefully that was good. Let's keep going. Let's do 9. All right. I want to isolate the radical. He's by himself. So then I have to cube it to make him go away. So the cube gets rid of the cubic root. I have x squared minus 1 equals 2 cubed is 8. I'm going to add the 1 over. X squared equals 9. And then I'm going to take the square root. And because we are doing the square root, x equals plus minus 3. So we have to put plus minus because we put the square root in there. So there is my solution to that. Okay, that was number 9. That was a really fast one. Okay, all right, let's go to the back side. Oh, these are going to be so nice. Number 10, hey, Carter, this one's for you, since you say this is the only thing that you can do right. Negative infinity to 4, bracket. Write it on a number line. 4 is my number. We're going negative infinity to 4, so we're doing one of these. And bracket means closed circle. Carter, you better have got that one right. Okay, there you go. That was number 10. That was fast. That was really nice. Okay, next, 11. All right, we've got 2 inequality symbols here. And what I'm going to do is I'm going to break this apart into like 2 chunks. So I'm going to focus on this chunk right here. 2x plus 3 less than or equal to 5x plus 6. Then, on the opposite end, I've got this chunk going on. I've got 5x plus 6 is less than negative 3x plus 7. And then I'm just solving the 2 pieces. Okay, so that middle chunk gets included in both pieces, and we just solve. So I'm going to subtract 2x, and I'm going to subtract the 6. Negative 3 less than or equal to 3x. Divide by 3. Negative 1. I did not divide by a negative. That's what he does. I can flip him around and say x is greater than or equal to negative 1. So that's what he does. Okay. Then let's do, I'm going to add 3x. Okay, and then I'm going to subtract the 6. So 8x is less than 1. Divide by 8. So x is less than 1/8. Okay, I'm going to put that on a number line. You don't have to, but I'm going to. Negative 1 goes here. 1/8 goes here. We are greater than or equal to negative 1, so we're going this way. And 1/8, we're less than 1/8. Okay, so really I could write that as one chunk together if you want. In interval notation, it would be bracket, parentheses, negative 1, 1/8. That's what he would look like if we want to write it as one chunk. Okay, so there's that. All right, I am going really fast through these. If you want to put a star by anything, make sure you note that, and I can go over any questions that you have when I come back. All right, number 12. Write the solution in interval notation. Interval notation is this guy. So he's an absolute value and an inequality. Inequality is this guy. So we got to do 2 cases because he's an absolute value. First case, 2 minus 3x greater than 4. Second case, and do it this as you please. You can do it a different way than I did. Negative 2 minus 3x is greater than 4. Okay, we'll talk about him here in a second because some of you guys are going to want to do that a certain way. All right, so let's solve this guy first. I'm going to subtract 2. Negative 3x is greater than 2, and I divide by negative 3. X is greater than negative 2/3. That's what he is. Okay, this one over here, you have options. You can either distribute through the negative and solve it that way, or you can divide by negative 1 to begin with, in which case you'll have to flip this sign. Here's what I'm going to do. I'm going to distribute through the negative, and here's why. This x is already negative, so now I have turned him positive. I don't have to flip my sign, but now he's positive, and now I just go ahead and solve. Oop, I'm going to add the 2. So 3x is greater than 6. Divide by 3. X is greater than 2. And that's what he is. Okay. Oh, we got to do interval notation. Let's slap him on a number line. What the heck? I got a symbol wrong here. Oh. Anybody yelling at me? Are you guys yelling at me yet? I didn't flip my sign when I divided by a negative. He's got to go this way. Right? Right? My signs were going the same direction, and that is not true. So, flip sign when times or divide by a negative. Okay, I caught myself. All right, so I'm going to do it on a number line. I'll zoom out so you can write that down. I've got negative 2/3 here. I've got positive 2 here. Less than 2/3, greater than 2. In interval notation, we would go from negative infinity to negative 2/3, paren, unioned with paren 2 to infinity, paren. This is my interval notation for that. Okay? All right, so hopefully that was good. Let's do a couple more. We got to get 3 more done. All right, we're going to FOIL this. That means multiply. So 2 times 3 is 6. 2 times 5i is 10i. I times 3 is 3i. And I times 5i is 5i squared. Okay, I'm going to fix him right away. I squared is negative 1. Write that off to the side over here. I squared equals negative 1. So anytime I see an I squared, I'm going to plug a negative 1 in its spot, which means this is not positive 5. This is actually negative 5 because you're multiplying. Now when I combine like terms, 6 and negative 5 makes 1. 10i and 3i is 13i, and there he is. Okay, that one was nice and quick. All right, 14. We're simplifying this guy, which means we're breaking him down. That's 23 i's all in a row. So I don't know what I is, or I to the 23rd is. I only know I squared. But I know that if I take I squared times itself 11 times, that gives me 22, right? I squared to the 11th power is 22. Times one more I, that will give me the 23rd one. Okay, so 2 times 11 is 22, plus another one is 23. All right, now I'm going to solve this. I to the second power is negative 1. So I have negative 1 times itself 11 times. Negative 1 times itself 11 times. That's an odd number of negatives, which is going to remain a negative 1. Times I to the first power. Negative 1 times I to the first power is negative I. There we go. Okay. All right. Do I want to write that down? Some of you guys like to write down the cheat sheet. Okay, I'll write it down. If it is a number that's divisible by 4, like I to the 4th power, right? If it's divisible by 4, you're going to end up with your answer being a positive 1. If it's I to the 6th power, he's not going to have an I in his answer, but he's going to be negative 1 because he's not divisible by 4. So if he's even, he's going to be either 1 or negative 1. If it's divisible by 4, it's going to be 1. If it's not divisible by 4, it's going to be negative 1. Okay? If it is an odd number, like I to the 5th power, or I to the 7th power, if it is odd, you are going to end up with this guy being a positive I. He's going to have 1 left over, but because 5 is 1 larger than 4, and 4 means positive, he's a positive I. Since 7 is 1 larger than 6, and 6 is not divisible by 4, he's going to be a negative I. Okay? So, if he's an even number, an even exponent, you're going to end up with 1 or negative 1. If he's an odd exponent, you're going to have an I or negative I. That's how he works out. Okay? All right, last one. Rationalize means get the I out of the bottom. We've got to multiply by 5 plus 2i and 5 plus 2i. Okay, so on the top, I'm just distributing. That will be 15 plus 6i on the top. Okay, on the bottom, I'm going to write out all my work. If you don't want to write down the part that you know is going to cancel, you don't have to. 5 times 5 is 25. 5 times 2i is plus 10i. Negative 2i plus 5 is minus 10i. And negative 2i minus 2 is negative 4i squared, which will change to plus 4 instead of minus 4 because negative 1, I squared is negative 1. All right, 15 plus 6i is what I have on top. On the bottom, the 10s cancel, so I have 25 plus 4, which is 29, and that is all. Woo, that was a lot. Okay, all right, tomorrow we'll do the next 15, hopefully. All right, but hopefully that was okay. All right, goodbye.